welcome back from the lab. I wanted to go through with you now some of the calculations to try to figure out what this all means. So we know we started out with 2 grams of sodium bicarbonate, and we know we ended with 19.6 was the mass of the crucible and the product. We know the mass of the crucible was 18.4, so we know we ended with 1.2 grams of solid product. But we're trying to figure out what that was. You know, is it sodium hydride? Is it sodium oxide, sodium hydroxide, sodium carbonate? You know, we've got 4 options of what sodium bicarbonate decomposed into, and how can we try to prove it using our evidence. So I wanted to walk you through option 1, and the first thing you'll want to do, of course, is have your balanced equation written and ready to go. So in option 1, it proposes sodium bicarbonate breaks down into sodium hydride, carbon monoxide, and oxygen. And remember, oxygen is diatomic, so it's going to be O2, and that our solid product was sodium hydride. Now, a couple of you have already probably are thinking, this can't be right. I don't think when I'm making pancakes and muffins, etc., carbon monoxide is being released. And you're on the right track with that thought. So let's try to disprove, let's try to reject the hypothesis that the product is sodium hydride. And we'll use our knowledge of ratios and chemical reactions to do that. So starting out, we know we started with 2 grams of sodium bicarbonate, and we want to figure out then how many moles is that. So let's go ahead and take our 2 grams of sodium bicarbonate and figure out how many moles that is. And to do that, remember, we want to multiply by a conversion factor. So how many grams is 1 mole of sodium bicarbonate? And so now would be a great time to grab your periodic table so we can try to figure out what is the molar mass of sodium bicarbonate. So we'll add up the mass of sodium, 23, plus the mass of hydrogen. 1 mole of hydrogen is 1, plus the mass of carbon. 1 mole of carbon is 12 grams, and plus the mass of 3 moles of oxygen, which is 15.999 or 16. So 3 times 16. So if we add all that together, we should get 84 grams. 23 plus 1 is 24, plus 12 is 36, plus 3 times 16 is 48. All of that added together should give us 84 grams. And you've calculated this before in class. And so that, when we multiply that out, we figure out that that is about 0.024 moles of sodium bicarbonate. And so if we want to know, eventually we're trying to get to, what should the mass of the product be? And so we want to keep going. And so the question to ask ourselves is, what is the relationship between moles of reactant and moles of product? And to do that, we use the coefficients. So in this case, the reaction was already balanced with 1s as the coefficients. So that means for every 1 mole of sodium hydride produced, I must have inputted or reacted 1 mole of sodium bicarbonate. And so for this first one, and I think one of the other ones, it is just a 1-to-1 ratio, and that makes it pretty easy. But there are a few that are going to involve a 2-to-1 ratio, and so you're going to have a different, a slightly different setup here. Okay, so far you can see grams will cancel out, moles of sodium bicarbonate will cancel out. We're trying to get our final unit, our final answer as grams of sodium hydride so that we can see, is this number close to what we got in the lab? And if it is, maybe that is the closest or best approximation of the equation. So what do we need to do? Right now we've got an answer in moles of sodium hydride, but we're trying to get to grams of sodium hydride. So we've got to figure out, again, the molar mass of sodium hydride. So how many grams is 1 mole of sodium hydride? And so, again, back to the periodic tables. Anybody remember the mass of 1 mole of sodium? 23. The mass of 1 mole of hydrogen, approximately 1. 23 plus 1 is 24 grams. And so now what we're going to do is multiply through, and notice that our units, the units that we don't need, are going to cancel out. So grams of sodium bicarbonate cancel out. Moles of sodium bicarbonate cancel out. Moles of sodium hydride cancel out. And we're left with a unit in grams of sodium hydride. So we ended up with, as a expected mass, if this were the most accurate equation, if this were the right equation, 0.57 grams. Is that close to 1.2? Not really. It's like less than half of what we should expect. Now, I'm not thinking that we're going to have a perfect, I don't think that our calculation will be exactly 1.2, and we can think about why. One of the things has to do with the number of decimal places the balance goes to. But I think this is not, I'm hoping that there's one equation that will be closer than that, because that is not very close. And so the last step is to figure out just how far away or just how much error is there. And so what we do to find that is we do observed, and maybe you've done this in math before. What did you observe versus what did you expect, divided by what you expected, times 100 to get it as a percent. And so we observed in the lab, we measured 1.2 grams of product. Based on this calculation, we would expect 0.57 grams. And again, we'll divide that by what we would expect based on this calculation. This ends up being like 0.63 divided by 0.57, multiply the whole thing by 100, and we end up with like 111% error. So that's not close at all. And so we are going to, you want your percent error to be like 10% or less. That means you're, how close are you to what you expected? Well, we are not even half. So our error is over 100%, which makes sense based on the comparison of these two numbers, and also helps us rule out option 1. Option 1 is not the most accurate equation. All right, I've made a data table for you so you can enter this information more easily and just multiply through. Number 1 is already done for you. We did it here and explained it, and I've already entered it into the data table. So now you just have 3 equations left, and hopefully by doing those 3, you'll be able to figure out which it is. All right, good luck. Let me know if you have questions.